Hello learners, and welcome to today's lesson of algebraic expressions, expand and simplify. In today's lesson, we are going to focus on those practice and application questions. So let's get to it. The first question there says, simplify the following expressions. Now, before we can simplify this expression, we need to remember that we have to only add or subtract the like terms. Unlike terms cannot be added or subtracted. So we have to now identify which ones are the like terms so that we can add or subtract them. Let's look at this given expression. Now we have been given there 4x cubed plus a 5y minus 2y minus 6 minus 3. So how can we simplify this expression? Well, firstly, we need to identify the like terms. Well, we can put the like terms together and maybe that will make it easier for us to calculate this or to simplify this expression. So we have a 4x cubed, and when we are looking at the whole expression there, we do not have any like term to that. Then we can write our negative 3x squared. So of course we know that those are not like terms. And why are they not like terms? Because they might have the same variable, but that exponent is different. But we do have there, we are adding a 5y and a 2, we are subtracting a 2y, then we have the subtraction of a 6. So now that we have rearranged our expression, just to see more clearly which ones are the like terms. Do we have like terms in this expression? Yes, we do, because the 5y and the 2y, they are like terms. So we do have the 5x cubed. Anything that's not a like term, we will just write it down as it is. So 4x cubed minus 3x squared. Now we are going to say 5 minus 2 because they are like terms. So 5 minus 2 is a 3. So we are going to be adding a 3 there, and that is 3y. And lastly, we have our constant there, which is a 6 that we are subtracting. And that is how we have simplified that expression, by identifying those like terms. Let's move over to the next question. Now, the next question there, we've been given an expression. Again, 5 plus a 20k exponent 5 plus a 13m cubed minus a 16k exponent 5 plus 2 minus 7m cubed. Let's try and write the ones that are like terms together so that it can be easier for us to simplify these expressions. So we have 20k exponent 5. Do we have anything that has a variable of k and an exponent 5? Yes, we do. We have that minus 16k exponent 5. So that 16 there is being subtracted. Then we have a 13m cubed that is being added with a 7m cubed that is being subtracted. Then lastly, we have our 5 and our 2 that are being added together there. So now we can see the like terms better. So 20 minus 16, we can subtract those two because they are like terms, the same variable with the same exponent. 20 minus 16 is of course a 4, and we are going to keep that variable with the exponent. Then we have a 13 minus 7. Now 13 minus 7 is a 6. So we are going to add a 6 there, and of course the m cubed. And lastly, we have our constants. They are also like terms because they are both constants. So we are going to have a 5 plus a 2, and that gives us a 7 that is going to be added there. And that is the answer to that expression, the simplified version of that expression. Now let's simplify the following expressions there. We have 8gh multiplied by 4h5. Now remember, when we are multiplying a monomial with a monomial, we are just going to multiply the integers. That is 8 multiplied by 4, and 8 multiplied by 4 is 32. Then we are going to multiply the variables together. Keep in mind those exponential laws. Now remember, if the base is the same, then we are going to add the exponents. This is when the powers have the same base. So we have a G, we have an H, and we have another H that has an exponent 5. So are there powers that have the same base? Yes, we do. We have here the H that has an exponent 1 and the H that has an exponent 5. So our final answer there is going to be 32GH, and that exponent is going to be, yes, you are correct, a 6. And where does that 6 come from? We have added the 1 and the 5. Let's go on to the next expression. So here we have 9k exponent 4 multiplied by a negative 7k. Let's multiply the integers together first. So 9 multiplied by a negative 7, that is going to give us a negative 63. Then we are going to multiply those variables together. So because they have the same base, we are going to add the exponents. So that is 4 plus 1. So negative 63k exponent 5 is going to be our final answer. Let's move on. The next one there is a binomial that is being multiplied by a monomial. Let's start with the first term of the binomial. Remember, each term of the binomial must multiply with that monomial. So now we have a negative 5 multiplied by a 2, that is a negative 10. Then we are going to multiply the variables together, and since they have the same base, we are going to add those exponents. Then we are adding in our binomial. Then we are going to say negative 5 multiplied by 4. That will give us a negative 20. And of course, because the base is the same with those powers there, we are going to add the exponents. So our final answer is going to be negative 10f exponent 6. And we are adding a negative number, which is the same as adding its additive inverse. So we are going to say there it's adding a negative number is the same as subtracting its additive inverse. So there we are going to say minus 20f, and the exponent there is going to be a 7. Let's go over to the next expression. We have again a binomial that is being multiplied by a monomial. 8 multiplied by 10, that is an 80. Then because the 10 doesn't have a variable, we are just going to write that variable as it is. And of course, we are subtracting in this binomial. Then we are going to say 8 multiplied by 4, that is 32. And those variables, they have the same base. And since we are multiplying, we are going to add the exponents. So that is going to be k 2 plus 1, because we know that there is an exponent of 1. And then what is our final answer going to be? 80k squared minus 32k cubed. Let's go to the next question. Now we are dividing by a monomial. And remember, when we are dividing a binomial by a monomial, we need to make sure that each term in the binomial divides with the monomial. Just like when we were multiplying, we made sure that each term of the binomial was multiplied by the monomial. So here we are going to make sure that each term of the binomial or a trinomial is divided by that monomial. Let's see what we are talking about. So here we have a 24m squared minus 6m, and these are both divided by 6. So we are going to say that negative 24 m squared, and that is going to divide by the 6, minus 6m, and that is going to divide by the 6. What is our answer going to be? Well, negative 24 divided by 6 is going to be a 4, and negative 4. And because there is no other variable, we are just going to write that power as it is. We are subtracting here in this binomial, so we are going to now say 6 divided by 6, we know that is 1. And of course, we're going to write that variable as it is. Let's look at our last practice question there. We have a trinomial that is being divided by a monomial. So we are going to have here 6n divided by 3 minus 9m divided by 3 minus 15 divided by 3. Remember, we said each term in the trinomial must be divided by this monomial. So let's go ahead and divide. So what is 6 divided by 3? That is 2. And we're going to write that variable as it is. Then we are subtracting here. What is 9 divided by 3? Yes, that is a 3. And that is going to be that m there. And lastly, we have 15 divided by 3. What is 15 divided by 3? Yes, it is our 5. And now we have divided that trinomial by that monomial. Let's quickly go to an ad break and then we'll see you just now for the rest of our lesson.